Hello, biologists. Welcome to lecture number 9. We're going to talk about climate change. So let's get started by thinking about our own perspectives. I want you to ask yourself the following questions. How do I know that something is true? Am I willing to change my mind when I learn new facts? Are there any topics that I flat out refuse to alter my opinion on? And I'm asking you to think about yourself for a moment because I think it's important to get yourself in the mind frame of where you stand and why you have that stance. So we all have opinions. We can't help it. We're human, but sometimes we're really deep-seated in those opinions, and our opinions are just that. They're opinions. They're not based on facts. So I'm bringing this up because Democrats and Republicans are more divided on climate change than they are on any other issue, including inequity, racism, and immigration. And that data is from the Pew Research Center in 2019. So we've taken a factual scientific phenomena, the climate crisis, and we've made it political. My assumption is that we have folks in this class that are Democrat and Republican and everything in between. So we may or may not agree on what we think based on opinions. And so I'm going to give us the facts about climate change. And the first facts I want to start with are our national facts about climate beliefs. 69% of Americans think that climate change is happening. That's a D. That's less than 70%. That means that 31% of Americans think climate change is not happening. Of the folks that deny climate change, there tends to be a trend of conservative white men denying it most. 55% of Americans think that climate change is caused by human activity. That's a failing rate. It is caused by human activity, and I'll show you the data in a few minutes. And then what's really interesting to me is 63% say that they rarely or never discuss climate change with friends and family. So that's national. Let's look at Oregon, right? Because we're Oregonians. We want to think about our own communities. Let's start with the beliefs. 69% of Oregonians believe that climate change is happening. Now, this resource uses the term global warming. We generally don't use the term global warming anymore because it's kind of a misnomer. Global warming makes it sound like the Earth is just going to warm up. And that's partially true. That is going to happen, but there's also other things that happen, and it's not just about the warming Earth. It's about the entire climate being altered. And so it makes it too narrow and it makes it too specific. In fact, calling it climate change is kind of being replaced right now anyway. And so we're trying to call it the global climate crisis because that indicates it's not just a change, it's a crisis. So our words matter. Global warming, some people still use it, but most scientists don't anymore. This and the next two slides still use it, so forgive these slides. All right, so 69% of Oregonians believe that climate change is happening. 54% believe that it's caused by human activity. 57% of Oregonians believe that scientists think it's happening. And 61% think that global warming is affecting the weather. Then there's risk perceptions. Only 60% of Oregonians are worried about climate change. That's pretty low compared to other states. 69% think that global warming will harm future generations. 67% think global warming will harm developing countries. Only 59% of Oregonians believe that global warming will harm people in the United States. And this is where it gets really interesting. 42% of Oregonians, so less than half, believe that climate change is going to affect them personally. It will. Even in our lifetime, we're seeing the effects. So really interesting. One more data set. Let's think about policy support. So 77% of Oregonians think global warming should be taught in school, which is so fascinating because if we go back to the last slide, only 69% thought global warming was happening, but 77% want it taught in school. Why would you want something taught in school if you didn't believe in it? And so there's a disconnect between the evidence and opinions about the evidence. So we want to teach it because we can see the data supporting it, but maybe we don't personally believe in it. And then that comes into the role of where do my opinions stop and where do I accept facts? And it's really, really fascinating. Humans are just incredibly interesting. So we got some red bars right here. 82% and 81% of Oregonians believe that we should fund research into renewable energies and that we should give tax rebates for energy efficient cars and solar panels. So those two things have good support, which is really encouraging. We do want to support solar and energy efficient cars and renewable resources. So that's awesome. 72% think that we should regulate CO2. 68% think that we should set strict CO2 limits, specifically on coal-fired power plants. So interesting. Then we get down here in behaviors. Both of these bars are gray. They're in the 40s, so less than 50%. 41% of Oregonians discuss global warming occasionally, and 41% hear about it on the media at least once a week. And this data is from 2019, so I'd be curious to see what it is now in the year 2021. I imagine that it wouldn't change a ton because we have other things going on in the news. And then this is my last little exciting public data part. Who should do more about global warming? The highest number, 70% of Oregonians think corporations should do more. Then the next high number, 65% think citizens should do more. So you and me. The lowest numbers, between 62 and 53, are our governmental officials. So Oregonians want individuals to do more than our elected officials. And that's fascinating. That could be a whole nother conversation. Maybe we can talk about that on Thursday. Now that we know what we think as Oregonians, as Americans, let's start looking at what climate change is. So climate change is when greenhouse gases get released into the atmosphere, thus affecting the climate of Earth. This is how the greenhouse gas affects, how it occurs. We have solar radiation coming from the sun. Here's the solar radiation. Some of it goes through our atmosphere and warms the Earth. Some of it's deflected by our atmosphere. And the part that's in our atmosphere will warm the Earth, and then some will leave and some will stay, except the greenhouse gas that is released into the atmosphere keeps this solar radiation in. So this little U-turn signal right here is the heat that would have left Earth previously being radiated back to Earth. It's called the greenhouse effect because it works kind of like a greenhouse in your yard. So a greenhouse is made of like clear panels, and the sunlight comes in and it heats the inside of the greenhouse, but then the heat can't escape, and so it's just trapped. So the greenhouse gases keep the heat in the Earth by trapping it in the atmosphere, same as the greenhouse that you may or may not have in your backyard. Our greenhouse gases mostly come from transportation. Now, when I say transportation, maybe your mind immediately thought of like the car that you use to take to the grocery store, or if you drive like a personal car. And that is transportation, of course, but there's also highways, there's trucking, there's shipping, there's railways, there's airplanes. Transportation is massive. Most of the things that I'm wearing or sitting on or looking at on my desk right now came to this country in big shipping containers, which were shipped across the ocean on giant shipping boats. Like, transportation is how we get most of our goods, unless you can only shop local, which is really hard and expensive. So transportation, bigger than just your own personal card. The next big chunk is electricity. That's powering my house right now. You can see that my light is on. But it's also powering the streetlights, water treatment facilities, all of our libraries and schools, and electricity, whatever you use electricity for. Then there's industry. Industry is going to be like manufacturing, production of goods, commercial and residential, so houses, but also office buildings, everything downtown in urban areas, and then agriculture, that last slice of the pie, agriculture. We could talk about cows when we think about agriculture. Cows are large producers of greenhouse gas. They produce much more methane, which is CH4, than other organisms do. And they take up a lot of space, and they require a lot of energy, and they require a lot of water. And so one of the most shocking statistics about what we can do for the environment is the single best thing you can do as a single person is to stop eating beef, because beef production produces so much greenhouse gas. Like, the amount of effort and energy and water and carbon that goes into making cow flesh is really, really expensive. So if you could transition away from beef, you'll be doing more than buying a Prius or riding your bike everywhere. It's absolutely fascinating. And we can talk about that on Thursday too. So now that we know where greenhouse gases come from, what are they? The biggest offender is carbon dioxide. So I'm exhaling it right now. My cat's exhaling it. Carbon dioxide, it's the product of cellular respiration, but it also comes from burning fuels, from running machinery, from livestock. Then the next one is methane. Methane is the main component in farts, fun fact, but also in cow belches. So cows are extremely gassy. They produce a huge amount of methane. Then we have nitrous oxide and fluorinated gases. So a greenhouse gas is anything that released to the atmosphere will help trap heat on Earth. That's what a greenhouse does, is it packs that heat in. We do have a correlation between the amount of CO2 in the atmosphere and the temperature. So releasing carbon dioxide does directly warm our planet. If we look here, we have the years before present, from 800,000 to 200,000 to 0. So this is present. Then we have temperature change, and we have CO2, carbon dioxide part per million. This graph is showing two different things, the carbon dioxide and the temperature. And you can see that when the carbon dioxide increases, the temperature increases. When carbon dioxide decreases, temperature decreases. So there's a direct correlation here between the amount of carbon dioxide present and the temperature on Earth. So if we keep releasing all these greenhouse gases, all this carbon dioxide, we're going to continually increase the temperature of our planet. We've been tracking this for since we started to realize it was a problem. And our data goes back 800,000 years ago. The 0 point here is the 1950s. So it's not right now, but it was, in current time. And since the 1950s, our atmospheric level of carbon dioxide has fluctuated between 170 and 300 parts per million. So 800,000 years to 1950s, all of this time, the number of carbon dioxide in the atmosphere has stayed below 300. I'm going to give you the most recent bit of the graph. Are you ready to be surprised? Here's 1950. Here's our current level. So 800,000 years to 1950, everything was below 300 parts per million. And then in the last, 71 years, we've gone up to 416. You don't have to be an expert at data representation to see what's happening on this graph. Like this is an incredible increase. It reminds me very much of the population curve. Like the population just skyrockets once we got industry. And that's the same issue here. Carbon dioxide has just skyrocketed since we started doing manufacturing and building and developing, and since our civilization started to get really complex and industrialized. I think this is a very powerful graph. I want to show you another version. This is the same information. So CO2 concentration in part per million. This is thousands of years ago, so 0 to 10,000 years ago. And we have our from 1950 increase right here, tops out right about there. So that's here. I got this data from ucsd.edu. It's called the Keeling curve. And I got it on April 19th, 2021. And the current carbon dioxide reading on that day was 416.46 parts per million. So you might be wondering how we know. And the way that we know is we have carbon dioxide detectors on the Mauna Loa Observatory in Hawaii, and it's pulling carbon dioxide concentrations directly out of the air. So we've been doing that since 1958. We've been collecting Mauna Loa data. We have it in other places too, but the Mauna Loa Observatory is rad because it's like in the middle of the ocean. So you don't get interference from the cars driving by. Not that there's not cars on Hawaii, but it's an isolated location. And then before 1958, which is when we really started monitoring this, we have ice core data. So all of this here, this is taken from ice core samples. And that's when they drill a chunk, like a biopsy, out of the ice, and they can find little pockets of gas, and they can measure the CO2 in it. They can tell the temperature based on it. It's really fascinating. It's really interesting data. So the last 10,000 years, and then industrialization. Just fascinating. I have two other graphs here. This one on the left is global temperature and carbon dioxide. I've got the year on the x-axis. Then we have temperature on the left. We have CO2 concentration on the right. This black line is the CO2 concentration. And then this bar here, where there's red going up and blue coming down, that is the annual global temperature average. So 1880 to, let's say, 1930. These years had a below average annual temperature. The CO2 concentration is increasing from 1980 to current. These years have had a above average global temperature. CO2 is increasing, the temperature is increasing. Here's another source. This is NOAA. You can see it in the background right there. National Oceanic and Atmospheric Association. So here on the bottom, it should have a label, but this is the year. This is the degrees in Celsius. This is degrees in Fahrenheit. And this is the annual surface temperature for the contingent US. This is the best fit line. This is the average. And then here is your fluctuation And you can see the best fit line is increasing. Our yearly temperature in the United States is increasing. This is a visual representation of the graph on the left. So here, I took this from an animation that you're going to watch during the lecture section. I took screenshots of it. 1884, this is the temperature difference from average. So 0, this is not degrees change, this is from average. 0 would be like this clear blue color, clear white color, whatever color you see right there. And then blue is colder, red is warmer. 1884, there were pockets of red and orange, but mostly over the land masses, it was blue. 2019, now there are a few pockets of blue, but mostly over land masses, it's just red. I want to leave us with, I think, 7 main takeaways. I've included the citations at the end. I'll show you them as well. The planet's average surface temperature has risen about 1.62 degrees Fahrenheit since the early 20th century. The 20 warmest years on record have all occurred since 1981. The 10 warmest years have all occurred in the last 12 years. So of the last 12, 10 were record warm years. The top layer of the oceans have warmed 0.4 degrees Fahrenheit since 1969. The Greenland and Antarctic ice sheets are shrinking, as are the Arctic ice sheets. The amount that we're losing of ice per year depends on where you are. In Greenland, it's about 286 billion tons of ice per year. In Antarctica, it is 127 billion tons, just billions of tons of ice per year that are being lost. Glaciers are retreating everywhere around the world, and the snow cover in the Northern Hemisphere has decreased over the last 5 decades. Global sea levels are rising and have risen about 8 inches in the last 100 years. The number of extreme events is increasing. That means record highs, record lows, storms, intense rainfalls, hurricanes, atmospheric rivers. And since 1760, the acidity of the ocean has increased by 30%. And the amount of CO2 getting into the ocean is increasing by 2 billion tons per year. Whenever I talk about global climate change, I have to check my emotional side, which maybe you're having to do that too right now. But I tend to feel a little bit powerless in situations like this, when I have to talk about it, when I have to show the data, and especially when you see that graph just skyrocket upward, and knowing that we're not doing enough to control it. But a wonderful colleague of mine said that the antidote to feeling helpless is action. And so you can get involved. Action is the antidote to despair. And I have a list of really reputable companies and organizations and governmental bodies that are doing good work for climate change. And several of them are not politically affiliated. So you don't have to be in one kind of political group to want to care about climate change or to get involved. And even if it's just helping out your own community, picking up litter, taking care of each other, that's important regardless what your political leaning is. So I recommend checking one of these out. I'll put this PowerPoint up so you have access to it. We've got National Geographic, Greenpeace, the Environmental Protection Agency, National Wildlife Federation, the Sierra Club, 350, which is named because the idea was that 350 parts per million was the safe amount of CO2 in the atmosphere. We're up to 416, so we've passed 350. The Climate Network, Environmental Justice Foundation, and the peoplesclimate.org. So each one of these would be a good resource, and we have local chapters. So there's a lot of opportunities to get involved. Since this is something that tends to be really dividing, I want to make sure to include my citations. Here are my citations in order. Please check them out. It's important to make sure that you know that I'm giving you good data. So look at them anytime you like. And if this left you with a lot of big feelings, know that you're not alone. None of us are alone in this. We're literally on the same planet. We're in this together. So let's talk about it. Let's try and figure out ways to have this discussion across political lines, because we're all humans. We all want the same thing. We all want to be safe and happy and healthy. So we got to work on how to talk about it. Thanks for a fabulous lecture, and I will see you on Thursday.